Okay, I'll give you some time to write this down. Again, we only have 3 examples today. And draw a picture. What I want you to be able to do, what you're going to have to be able to do later on, is you're going to have to come up with equations on your own. Okay, this question, the equations were given to you. What I want you to do is once you're done writing it down, see if you can reread the question and see if you can make sense of where those equations come from. Tell me what the D stands for. Tell me what the T stands for. Tell me how you could get those equations, because that would be something you would have to come up with. Someone figure out what the D stands for? Distance. Distance from what? From where? Okay, so D is the distance from Tyrell, or however you say his name. Distance from Tyrell's place. And T is time since they began. Okay, good. Now, why is it? Let's start with this second equation. This is Tyrell. This is Tyrell's equation. Why is it 2.4t? That's how fast he's going, and at time 0, he's right at his house. The distance from his house would be 0. Why is there 6 in the other equation? Is she going 6? No, she's going 4, but they're 6 kilometers apart. Okay, they're 6 kilometers apart. So at time 0, she's actually, what if I put a 0 in for t, she would be 6 away, because she's over here. But then at time 1, she's getting closer to Tyrell's place, right? So that's why it's minus 4t, and the other one was plus 2.4. His 2.4 is a positive number because he's going away from his house, so he's getting farther away. And hers is negative because she's going towards his house. Okay? Are these both in y equals mx plus b form? They're close though, right? Can you see the first one? If you just rearrange the first one, I'll do it in blue. D equals negative 4t plus 6, then it would be. In this case, our D is like y, and our t is like x. And the second one, which I'll do in green, is already in that form. But if I was going to graph this by hand, a decimal is a little bit hard to do. Can we change 2.4 to a fraction? Okay. Close to 5 divided by 2, which is 2.5. But how do we change things to a fraction? Do you know how to change 0.4 to a fraction? 4/10, right? Because that's what those are. So we can start off by saying 2 and 4/10. That's a mixed fraction. Can you simplify the 4/10? That makes 2 and 2/5. Can you change that to an improper fraction? And we get 12/5. That's nicer because now I know I have a rise of 12 and a run of 5. So now when I go down to graph this, say graph and find where the two graphs, oh, and there's a typo on here. Did you catch that? I put intercept instead of intersect. Oops. Now when we go to graph this, I'll graph the one in blue, negative 4t plus 6. Well, that is a y-intercept of 6. And negative 4 means down 4 over 1, down 4 over 1, and so on. So here is my one line, my blue one. What is the y-intercept of my green line? It's in y equals mx plus b. Look at the green equation. There is none. So that means it is 0. You could imagine a plus 0 there, but it doesn't have to be written. Now the rise over run is 12 over 5, positive, so it's going up from left to right. We would have to go up 12 over 5. Now the only nice point that we have on our green graph is 1 right here at 0, 0. And the next nice point would be up 12 over 5 is over there. The next nice point we'd have to go up 12 and over 5 again. Do these two graphs intersect at nice points? No. Even though it's really close to this one, and you might be tempted to bend your line to make it go through so that you have an easy answer, the only way that you can do this by hand and have a nice answer is if the points actually are exactly at the same spot. This one doesn't have 2 points that are exactly at the same spot, so we're going to have to go to our graphing calculator and type them in. My blue graph was negative 4x plus 6. I'll go down to green. My green graph was, and you can put the decimal in or the fraction, 2.4x. You might have to hit your zoom button. Depending on how you set your window, I push zoom and go back to number 6 as a standard window to start to have a look at what this looks like. Is everybody able to get both graphs on their graphing calculator? Anybody forget their calculator today and like to borrow one? Grab one. So once you have both graphs on there, we want to find out where they intersect. Every calculation for graphs is above the trace button and calculate. So hit your second button and then hit your calculate button. And of these, which one do you think we're going to use? Number 5, intersect. What's always going to happen is your cursor is going to go on one line. It'll ask, are you on your first line or first curve? You push enter. Are you on your second curve? It automatically goes to the second one. You push enter. It asks you to guess. You just push enter again, and it will always find where they intersect at 0.9375 and 2.25. So I'll label that point on my graph. This point right here is 0.9375, comma 2.25. What does this point mean? This point means at 0.9375 hours, just less than 1 hour, at 0.9375 hours, they meet at a distance of 2.25 kilometers from Tyrrell's cabin.